That comes down to an interesting idea that Java supports as a first-class idea, which is the distinction between a list and an array list. I mean, I did this. If you took AP Computer Science, you probably never did code that looks like this. You probably just said array list L equals new array list. But I do want to highlight there's this interesting feature in Java that there are many different types of lists. So if I go here to this link, I can see all the different classes that are lists. So for example, there exists, let's see, there we go, array, oh yeah, array list, there you go. Yeah, it's at the very top. So there exists array lists, there's copy on write array lists, there's linked lists, role lists, stacks, vectors, all of those things are lists of some kind, and they all are different choices that a Java programmer can in principle use if they're gonna use a list. The most common thing you'll see people use is an array list. Sorry, let me just fix this up. So the most common thing is to use an array list, but I could also, like I could use array list, I could use linked list, and they'll both behave like lists. They might have different speeds of different operations, but they're two different choices. In Python, by contrast, there's no distinction between the abstract idea of a list and an actual list. They're the same thing. A list is a list is a list. You don't really have a choice of what type of list. I mean, there are other kinds of data structures, but the only one that you get out of a bracket in Python is, this is just the plain old normal list. But in Java, there's many types of lists that all use the same syntax, that they're all of type list. Okay? And so I could in principle do array list or linked list. The programmer gets to decide what type of list when they instantiate a list. And whenever you write code that operates on lists, you don't know which type you got. Now I should note that in Python this is also true to some degree because there's this notion of sequences that you learned about in 61A. But here, I think there's a bit more of a formal distinction. They are all capital L lists. That is, that somewhere in the Java language, there's a definition of list itself. And what a list is it's all the classes that have exactly these methods that are look here. Like every list has a get method that gets the indexed item. Every list has an index of method that can try to find something in the list. Every one of them has an is empty method, and they all have exactly those operations. And there are many different choices of such lists. So each implementation is called a concrete implementation, and the code for those different implementations could be completely different from the others. But all those implementations are guaranteed to have at least the operations in the list interface. Okay? So why bother having lots of these things? What do you think? Like, why are there many types of lists? We had to speculate. Yeah? Some are faster than others at, you said? Right, yeah. Exactly. That's a great answer. So for example, the linked list class is really fast at adding things to the front, and the array list is not. Yeah. Yeah, you might have issues with memory, maybe if they're gigantic in some way, yeah. Some better readability in what way? Oh, mutability, right. I mean, it's possible they have rules about how they could be mutated, maybe in like parallel programs, that sort of thing, yeah. So they may have better performance in certain cases. For example, linked lists, as I said already, are fast at the front item. And actually, you can have additional operations. So the stack implementation of a list has extra operations called push and pop. And we'll talk about this sort of thing in more detail starting next week.